Hey, I'm super excited to be here today. I'm here to talk about how PostHog moved from Postgres to ClickHouse and how we made this ClickHouse our event mansion. My name is James Greenhill. I'm a software engineer here at PostHog. I've been here for almost 4 years now. And yeah, it's been a really interesting experience. Have learned quite a lot, and a lot of it has been around ClickHouse and the OLAP ecosystem. So jumping right in. Oop, there we go. What is PostHog? PostHog started out as an open source product analytics software, but really has turned into a open source product ops sidecar because we've moved on just from solely doing product analytics. You're sending us a bunch of data. One of the things that we do really interestingly with that data that involves storing the data is leveraging that data in other products. So we have funnels, sessions, session playback, so session recordings, feature flagging, experiments, cohorts, surveys, data warehousing, and a lot more. So the idea is you basically send us data and we leverage that data as much as we can. It's not just analytics on it. You can go in there and say, okay, I want to look at a funnel, create some cohorts from that funnel, feature flag, do some experiments, and see how conversion changes for different cohorts that are getting different treatment groups. The neat thing about PostHog, like I mentioned a little bit earlier, is we are completely open source. So this is something that you can host yourself. You can dive into the weeds, see how we're doing this. We basically operate in the open. That's one of our cultural values. And so if you're curious about how this all works, you can check it out on GitHub. So defining characteristics of how we store data at PostHog. One of the things that we want to do, like I was mentioning, is we want to store the data in a way that is leveraged, that we can leverage from other products really easily. And a couple defining characteristics of that is we want to make sure that our product is as close to real time as possible, meaning that when you send data, you see it almost immediately. So when you're sending an event, when you're instrumenting your application, you see it in our Events Explorer almost instantly. It helps basically get that positive reinforcement that you're sending the events correctly. It means that if you want to see if there's an incident occurring on your application, you can see it. You can see real-time impacts of things that you're doing on the app. We also have a continually growing feature set in our application. This is really important for whatever OLAP solution that we're using. We don't want to be have silos of data within our application that make it really difficult to build new features. We want everything just to be basically a new product to be a new query. And that's it. The system should be able to accept and filter on arbitrary user-defined properties and event payloads. So something that's special about what we offer is that you can send us events, custom events that have custom properties. It's kind of you can put whatever you want in there. You can say, include the number of items in the cart when someone adds something to your cart or is in the checkout flow. You can add on person details, person properties, and then you can later filter and aggregate on those properties. Whatever the way that we build our system has to accommodate those query patterns. And one of the things very early on that was very important to us is the ability to host the stack yourself. So early in PostHog's career, we didn't really know whether or not we were going to do self-hosted exclusively or if we were going to do SaaS. We were really figuring things out. And we wanted to, whatever solution that we chose, we wanted to make sure that that solution was going to be compatible with hosting yourself and not overly burdensome. Because a lot of times, my background is primarily in the Hadoop stack. When I cut my teeth on Hive and Presto 10 years ago. And managing that stack is really tough. We had Hortonworks and Cloudera, and that made it a lot easier, but it still was tough. And one of the things we really did not want to do is push that onto our customer. We didn't want to say, okay, you want to have self-hosted product analytics. Here's the Hadoop stack. Have fun. We really wanted to make it our ICP, our ideal customer, is the small company. People two founders trying to figure out how people are using their application and see where people are having good and bad experiences, diving in and kind of figuring out where they need to invest time to improve their app. Or if you have a small engineering team, time is your most valuable resource. Where are you going to have your team work? What bits of your application need watering? And we didn't want them to be distracted by having to manage a huge stack that was just going to be a distraction away from what they were going to be working on day to day, which is the most important thing that they need to do is their product. And also, one of our core things is you own your data. If you host it yourself, you have control over your data. If you need to have if you need it extremely controlled, you can do that. Inside it, like we have several air gaps installations still to this day. So version 1, this is what we came out of YC with. So demo day, the James Hawkins and Tim basically had to have something. The quickest way to build this out, they actually had multiple pivots, which is a completely separate talk, which is really interesting. They actually have a talk on this. But basically, they came up with the idea of PostHog for scratching their own itch. They had to build it really quick. And amazingly, they did build it out, almost feature complete, with Django and Postgres. It's originally built on, like I said, Django, Postgres, ORM. So they weren't even writing queries against Postgres. They were building out Django ORM queries that were analytics queries, which you should have seen some of the SQL that it built. It was wild. I mean, like multi-page, if you were to print it, multi-page SQL queries, self-referential, it was a nightmare, but it worked. So PostHog, one of the reasons why they did this, a lot of the things that we were building were relational. It's what we knew. It's very well supported by the community. It's easy to adopt really early on. And if you have small data, it's fine. If you have under, let's say, 10 million events, no big deal. Postgres actually does quite a great job at this. We also, at the time, were using Heroku Postgres because we had credits as part of YC. They give you a sizable amount of Heroku credits. One of my favorite things, one of my favorite sayings is, your infrastructure dies where it's born. And this is definitely one of those cases. We are no longer on Heroku Postgres, but we were on it for a very long time with the very largest standard 9 instance. Finally, we got off that, but long story, another talk. However, so we at first were like, okay, we need to move off of Postgres onto something. We looked at a bunch of stuff in the industry, things that I had used previously, things that my friends had used previously. Pinot, Presto, Druid, Timescale, all of these are really great solutions. Pinot, we were using at Uber for Uber Eats dashboards for customers, very solid software. Presto, that's basically what Athena. It's a data warehousing juggernaut. Druid is really powerful. Timescale DB, there are a lot of really interesting posts between Timescale and actually ClickHouse. Citus DB we used at we used at Discuss, where I was working previously, and also Sentry demoed Citus as well. Is very Postgres-y, very familiar, comfortable, and then ClickHouse. And it came down to really 3 things here: speed, complexity of management, and the query interface. So really the thing that we wanted out of the box was we wanted it to be fast without too much tuning. And the idea here is, again, we're going to be shipping this to customers. We basically were going to build a Helm chart, and we're going to bundle all this up, a data warehouse in a box effectively, and say, here you go, deal with it. And a lot of these are very, very fast, but you have to get in the weeds of managing it. You have to get into the weeds of optimizing things. And ClickHouse actually was very good out of the box at being fast. Complexity of management, again, this boils down to separation of storage and compute. So ClickHouse has tightly coupled storage and compute. It's a lot more like a Postgres than it is like, Presto, where you're going to be querying, you're going to want to set up HDFS or set up S3, and then have your compute allocated separately. We just wanted to say, here's your one instance that's very fast and will get you really far. And then once you grow beyond that one instance, we can kind of talk. And the query interface, one of the things that we really wanted we're all really big into SQL. We like SQL as a language. We think it's very expressive. It's a lot easier to iterate an analytics product and build new products with, in our opinion. So that was kind of a requirement. So how do we make this decision? We reviewed a ton of benchmarks. Altinity and ClickHouse both have a ton of benchmarks. We benchmarked a ton ourselves. We actually should publish that. They're pretty old now, but it was quite a bit of benchmarking at the time. Look to see, and the other thing that we did after benchmarking, and the benchmarks were clear winners, was talk with people. Say, hey, how was your experience with ClickHouse? Is this a bad idea? Are we going to regret it? Sentry, we have a lot of friends over Sentry who basically did this migration just prior to us, and they moved everything over from a bunch of pre-calculated Redis databases into Citus and then ClickHouse eventually. And they loved it. They had a lot of struggle. It wasn't a really straightforward migration, but in the end, it worked out quite well for them. Cloudflare, they have a blog post, famously had 6 million requests per second getting logged into their ClickHouse cluster. They actually had just a blog post recently about how their ClickHouse cluster and Kafka infrastructure caused one of their most recent outages. But I mean, it just shows how much they're leveraging ClickHouse for their analytics infrastructure. Uber is using it for logs, Yandex, of course, and Spotify. So after talking with a number of these people and saying like, hey, what were the good and bad experiences? We basically decided to take the plunge and give it a try. We set up a test cluster and we were honestly blown away by the speed and ease of setup. And this first test cluster was definitely not configured correctly. Got to go fast. That's basically our motto. So what is ClickHouse and why is it so good? ClickHouse basically was built internal to Yandex for Yandex Metrica. And Yandex Metrica, if you don't know, is basically Google Analytics of Yandex. It handled, at the time, 20 billion events a day, over 13 trillion records in total. Reports are built on the fly from non-aggregated data. This is really important because one of the things that we wanted to avoid, and what I had gotten burnt on in the past, is building out a bunch of custom tables. Now, it works out really well in a data warehousing situation, but if you're trying to move fast, you really don't want to have to rework a table and then backfill, rework a table and then backfill. We wanted to iterate on our product extremely quickly. And again, open source, like our self-hosted, it's hard to run backfills on self-hosted infrastructure. So if you have a bunch of people running your product and you're saying like, hey, we've updated this table, you don't like have to run an Airbyte instance or Airflow instance locally for them to manage that orchestration. It's hard enough just doing normal migrations on ClickHouse. The idea of doing like N+1 different tables of migrations, it was going to cause a lot of problems. And so what we wanted here was the fact that you could just modify your query. The data in the schema stays the same, but the query can be changed and the results can be changed. Was really powerful. ClickHouse is a column-oriented database. This is kind of table stakes for any OLAP database out there, but the fact that it is and it uses the merge tree is fantastic. Written in C++, and the tightly coupled compute and storage is a huge win. So again, what makes it special beyond the table stakes of a OLAP database? Compression. So because of that tightly coupled compute and storage is not cheap. When you dump things to S3, it's actually pretty reasonable. But when you're using local NVMe or EBS, GP3, or even ST1 on AWS, like it adds up quick. And so you want to get as much mileage out of that storage as you can. And from our benchmarks, it's like some of our columns, we get compression of like 95%. It's wild, especially if you low cardinality tables, or low cardinality columns. It's fantastic. It processes data from disk, is very cheap. It does joins from disk. Some of the alternatives, you have basically, if it doesn't fit in memory, you're kind of hosed. So this allows us to use smaller instances for our on-prem customers. Vector computation, SIMD, like single instruction, multiple data, it's just outrageously fast with this. One of the things that ClickHouse says on their blog, and it is true, is when you run a query on it, it will use all of the resources on that box until that query is done, and that is the goal. And it does that. It's quite good. It supports Neon for ARM. It supports a lot of the AMD 64 SIMD instruction sets. It's nice. So near real-time data updates based on sort key. This is something that kind of goes towards one of our first goals for the entire platform. We wanted the data to show up relatively instantly, minutes, right? We didn't want to have to wait for like an hourly or daily job. We wanted the data to show up. Sorted data allows for primary and secondary indexes. So the way that, and we can get into this later with the storage engines, but the way that ClickHouse stores data on disk is incredibly simple. It uses a log structured merge tree. That's why it's called the merge tree table. And basically the way it does is sorts it on disk, and then you can have multiple projections pointing to the same table, and then you have data skipping indexes. You have a couple different types, min max. You have I'm forgetting the name of it, but Bloom filter. So basically you can have the database roughly know where it needs to go and then know whether or not it needs to skip the granules on disk. It's incredibly powerful. So even though it's really fast out of the gate, it's even faster if you just kind of apply a couple of these optimizations that are available to you in the toolkit. No query planner. This is good and bad. So at first it was very good because it gave us incredibly deterministic query times. But the bad part is, as we become slowly, we're turning into a little bit of a data warehouse, like a baby data warehouse, where users can actually generate their own queries. Having a query optimizer would be really nice. So this is a good and bad. The nice thing is, if it's fast today, it's fast tomorrow. You don't really have to worry about the query planner switching up the strategy for how it's going to execute the query. The downside is, if you do give it a query that is kind of like, user generated and not exactly optimized, it's not going to optimize it for you. Support for approximated calculations is really great, because a lot of the times you don't really need to put everything in memory. You can just get like a quantile that's an estimate. It works great. And easy replication and sharding, more on that later. So it is very easy to add a replica. Resharding is not so easy. What makes ClickHouse painful? Oof. Mutations. So because it's a log structure merge tree, when you do a mutation, so write to be forgotten, or if you have a customer who wants to rewrite some of their data because they made a mistake, it's very expensive. You basically have to rewrite all of the parts for all of the partitions that are affected, which, if your data is really big, it's actually pretty taxing on IO. While you're doing this at the same time as mutations occurring. Transactions are not supported, which is fine, but it's kind of like it would be nice if they did. Says every OLAP engineer in the world. Sparse indexes are not real indexes. If you are trying to do point queries, you're going to have a bad time with ClickHouse. One of our use cases for our OLAP data is feature flagging. Almost everything that we do huge scans over the data, right? Like, we're trying to do aggregates. We're trying to come up with like numbers for a dashboard. We're not really grabbing like, this user, tell me more about them. Except for one product, and that's our feature flagging and experiment platform. That platform does require us to grab single points, and really quickly too, right? We need to make a decision. We need to know whether or not we need to like give this user the control group or treatment group or what. Not good for that. So we actually have to use a different data store for that. We use Postgres. Still, we use Postgres, and it's challenging. Another talk. Resharding is painfully manual. So you can't just, it's not like Cassandra in a ring, and you just kind of like add nodes and it just distributes it throughout. You do have to reshard manually. You use ClickHouse Copier. You can do other things to do this, but basically it's a manual thing you got to do. It's pretty intense. So what is an event mansion, and how have we turned it into this? So again, users should get as close to real-time results as possible. ClickHouse performance, along with some clever architecting, allows us to continue providing users with near real-time results. So check. There's a continually growing feature set. That's one of the things that I absolutely love about the ClickHouse ecosystem in general, the open source product and ClickHouse Cloud. They just ship. Like, if you look at most databases out there, it's like, for instance, Postgres, like incredibly wonderful technology, and it is like dependable, right? But one of the things that ClickHouse does that I love is that they're just fast. They ship so many new features and things all the time. Sometimes it does cause rough edges and sharp edges. We've hit a couple of them, but overall, like, it's, in terms of technology to bet on, it is fantastic technology to bet on. The system should be able to accept and filter on user-defined properties and event payloads. That was one of our requirements. Things like extracting from JSON, that basically deserializing JSON is we're going to get to that later, but deserializing JSON is very, very fast. It is CPU intensive still. It does use SIMD, it's JSON SIMD, but it's very powerful at that. And there are optimizations that we can do to make it even faster. And the system should be easily deployable as possible to cater to users who want to own their data. So because of these things like the Kafka table engine, we were able to ship a Kubernetes chart very easily with fewer moving parts, just because ClickHouse could consume from our data pipelines directly. So initial learnings. We tried to do a couple optimizations that did not pan out. Don't do this to yourself. We tried to extract JSON keys and values instead of just storing the string. We tried to have like arrays of keys to values and match those up. We tried to have a key value lookup table. It was even slower. Eventually, we leveraged use Columnar. Like, it's just, if the toolbox if the OLAP database is a Columnar database, just leverage that even more. Dive deeper into that. Basically, for that, we used materialized columns. And we'll get into that in a second. JSON extract string is surprisingly fast, but still CPU intensive. I have a flame graph showing just how expensive this is on large objects. One of the things for us and most companies, if you ever give an engineer the ability to give you JSON, you're going to end up with a huge object, always. Like, this is why, like, Snowflake has an entire, in their paper, this is the reason why they came up with a variant object. They knew this was going to happen, and so they baked the optimizations into their engine. That's the exact same thing for us. We basically give our users a blank check with the JSON properties field. They can put whatever they want in there, and they can filter on whatever key is in there. And so giving them, having the ability to dive into that JSON payload quickly is important. It does it. Developed our own way to serialize DOM hierarchies to make querying the DOM very efficient. This actually worked really well. So one of the things that we do for websites is we do auto capture. And auto capture, the DOM for web, for browsers, basically, is a hierarchy. You know, a child has multiple parents, and we want to capture all of those parents so you can query on that DOM hierarchy later. So when you can basically say, did the user click this button, and use, you know, the ID of the class or whatever in that DOM hierarchy you want. The way we did this here was we actually serialized the DOM hierarchy into a string, and then we compile regex to hit that string. This would be incredibly slow if it was not for Google's RE2. RE2 is incredibly fast and constant speed. So, like, depending on the length of the string, basically the speed up of the string, or of the time it will take, just is linear. Fantastic. Worst case. Don't mutate it if you can help it, and use materialized columns. So how do we make the switch? We basically built out feature flagging, and we set up a completely parallel pipeline and set a couple of users on that new pipeline. Like, we built feature flagging to do this migration, and it worked fantastically. And, you know, as we were having problems, we just migrated back. Like, we would just move people back for that specific use case in the application. And now that's a product that we use for everyone. All right, how do we deploy ClickHouse? We basically have, we way over provision this. We basically have one giant cluster for the US. We have a couple other clusters, but for the US, we have i3 12 extra larges with local NVMe storage. That has bought us a lot of time because merges are expensive, and we were doing a lot of mutations, so we were actively rewriting data all the time. If we hadn't done this, it would have been a very different story, I think. But we still use this cluster to this day. We've increased one of the interesting things with ClickHouse is you can do heterogeneous cluster setups. So we have the online cluster and the offline cluster, but they're replicated from the same table sets. And we've optimized the offline cluster for long-running queries and the online cluster for very quick user queries. We also, for on-prem, developed a Helm chart that you could just boot up instantly using Altinity's ClickHouse operator, which is fantastic. If you have any interest in running ClickHouse in a Kubernetes environment, you should check that out. Speeding up because I'm running low on time. ClickHouse, so these are our clusters, online, offline. The offline cluster has actually gotten quite large. In total, we have 320 vCPUs, 2.5 terabytes of memory, 30 terabytes of NVMe, ephemeral storage, and then 112 terabytes of GP3 that we use. Basically, another reason why ClickHouse is fantastic in our mind is you can tier. So you have that tightly coupled compute and storage, but you're able to tier out your storage so that you have really expensive fast for your hot data, and then slowly evict it out to slower and slower data, and then eventually to S3, which is lovely. Like, you basically get the speed, but you also get, you don't have to like evict the data out of your cluster altogether just because you're running out of space or you have cost constraints. This I'm not going to go into too much, but this is basically the architecture of our on-prem Helm installation. If you have any questions about this, I will be in the ClickHouse room afterwards, or you can reach out to me directly on LinkedIn. ClickHouse table engines are really fantastic. They are one of the reasons why I love it personally, just because you have so many options in situ to store your data. We use almost exclusively replacing merge trees because they do dupe your data for you. Wonderful. Collapsing merge trees, version collapsing merge trees allow you to store the data and update it. And basically you have a field that you can set as like, this is the new version of the row. And when the database does compaction, when it does merges, it'll eliminate the old rows. Really convenient. Kafka, I was mentioning, this allowed us to basically hook ClickHouse directly into Kafka and not have to worry about how we were consuming data from our Kafka clusters. Which we like, that separation is a whole nother talk. Like, one of the reasons why we could do this migration is because of this Kafka table or Kafka, like the separation of our app, so we can have two different consumers. Distributed, materialized views, materialized Postgres. This is an interesting one. It reads from logical replication streams and materializes that into a table. So you really don't have to, like, you can have live data from Postgres in ClickHouse if you want it. And then finally, S3. Okay, so to ORM or not to ORM. Basically, originally we used the Django ORM. We were like, do we want to use an ORM for ClickHouse here? We decided not to. We all like SQL. We wanted to be able to have like really deeply optimize our SQL queries. And so we basically just, if you look at our repo, it's just a bunch of templatized SQL for all our products. And so far, it's worked out quite nicely. I would suggest the same. Keep it simple. It'll make things more maintainable. And especially if you have something that you didn't anticipate, like a product that you didn't anticipate, and you have to rework the ORM for it, like this just is a query. It works nicely. Or if there's a new feature that you want to leverage. Testing, integration tests basically is how we do this. We do snapshot tests with Syrupy as well. We test the entire stack end to end every time we ship a PR. We boot it up, put some data in it, make sure the results look exactly like they should, and it works. It's quite nice. Even with Kafka, we do this. Our optimizations. So we optimize, this is the JSON optimization. We had some slow queries. We wanted to understand why they were going slow. We basically, system tracelog gives you, like with a tool, you can basically create a flame graph like this to see where the cluster is spending time. We saw that it was spending time on JSON. What we ended up doing here was we created materialized columns based on query patterns. So we materialized the JSON fields that people were querying. So when at query time, we route that to the materialized column, makes it way faster. How much faster? It's 3.4 times faster, 81% reduction in bytes read from disk because we're not deserializing all that JSON. And again, this is based off of the query log. We basically read the query log, profile the queries, see what people are querying on, and then materialize a column on a job that happens on the weekend. We also do this for one-offs for large customers that have like weird, not popular key names in JSON, but it works just as well. The future. All right, so in future, materialize, pre-calculate more data, actions, materialize Postgres. That is something that I'd like to look into because it would simplify some of the issues that we're having around keeping those two in sync. That's an evergreen issue with all OLAP solutions. Zero copy replication, S3 back merge trees. Those, for me, are really interesting. ClickHouse Cloud has alleviated a lot of this. So there are really two things here. You have, if you host it yourself, you want to be able to tier out your storage on your cluster so that you have everything in, like I was saying earlier, like really fast storage at first. Use that ephemeral NVMe if you have it. Switch it over to GP3, so whatever it would be in GCS, but basically like fast block storage backed by SSDs. You could even use like IO. If you wanted to, but that would be quite expensive. And then tier it out to ST1, SC1 if you can handle it, but really tell ClickHouse not to merge on that. And then finally, you can use these zero copy replication S3 back merge trees, which are really interesting, especially for tables. Like I wouldn't use this as part of the tiering strategy, but this is really interesting for large tables. So a real quick story here. If you look at how we implemented session recording, so session recording is one of those things with our product that allows you, let's say you're looking at a funnel, and as an engineer, it's like, or even a product manager, you're looking to see, you're saying, okay, people are bailing out after adding items to your cart. Like they're just not converting. You're able, using this to, using session recordings, you're able to see exactly, like dive into those bad experiences on the app and see exactly what's going on. Are there exceptions being thrown? Is the UI confusing? And the way we were storing that was in ClickHouse for a very long time, which is a little bit of abuse of how we should store data in ClickHouse. But with these tables, it would have been very easy because you could store blobs. It's very, very good at just retrieving those blobs back, especially if it's on S3, the storage gets quite cheap and replication doesn't add up your costs. Shared merge tree effectively obviates that. So ClickHouse Cloud has developed this thing called a shared merge tree, is effectively zero copy replication in S3 back storage. You have one shard, multiple replicas can read from that one shard. It makes the cluster elastic, which is fantastic. Again, like resharding a cluster is very manual. So that's something that I'd love to spend more time testing. I'm actually spending a lot of my time right now working on that. Investigate and benchmark cluster topologies is another one. Tinybird has several blog posts on this, like should you have big tall clusters or short, like wide clusters with a bunch of nodes. And then finally, what I'm spending a lot of my time on and our team's time on is ClickHouse management tooling. And that wraps up. So should you have any questions, I'll be in the ClickHouse room. Feel free to drop by. I would love to talk with each one of you and answer any questions you have about ClickHouse or PostHog. And thank you so much for having me. This has been a really fun time.